How's everyone doing? Good. So if you see my talk in the schedule has a very long title, so I tried to make it shorter so it fits on the title page, but the content is the same. Today I'm going to be talking about, as the first speaker, about large language models, specifically about some of the work we're doing in my lab at Dartmouth College with regards to their tendency to produce sometimes antisocial generations. And antisocial here being the opposite of prosocial corresponds to everything you've been hearing about lately about the safety of large language models, biases, stereotypes, hallucinations, their lack of transparency, for instance. And we're interested in not only studying these issues, but work on methods for mitigating them. Just before I go any further, I just want to thank my lab for all of the work that I'm going to be presenting today. As we all know, everything we talk about is actually done by our students, which are right here at Dartmouth College. So my lab at Dartmouth is called Minds, Machines, and Society. It's part of the machine learning lab in the Department of Computer Science. And our lab has a very unique view. Well, I guess it used to be unique when we started. Now it's actually not super unique. And there's other labs that also do this. But we have a heavy emphasis on social science in addition, obviously, to machine learning and natural language processing. So our work is actually right there at the intersection of the three areas. We are interested in looking at social problems, not just because they're interesting technical problems, but we're actually interested from a social science perspective as well. Sometimes people call this area computational social science, but you can call it whatever, but it lies at that intersection right there. So we all know, I don't have to motivate what's happening in AI right now in large language models. We have these huge models. Well, ChatGPT uses a large language model. They're neural net deep learning based. They're huge, they're opaque, but they work really well. But they also tend to have antisocial generations that we need to deal with. And as this audience knows, but I add this always to my talk because most people don't realize this thing, language models have been around for a long time. In fact, GPT-3, there was this article in The Guardian in 2020, that's 3 years ago, and this was written fully by GPT-3. So this generation capability of large models that we are now has all over the news, it's been around for quite a long time, and similarly, the issues with large language models have been known, these social issues, safety issues, for quite as long as well. And so we've been working on this problem for several years now. It just happens that this year, because of release of ChatGPT, it's all of a sudden is all over the news. But it is a problem that we've been aware of, and we here, we in the field for quite a long time. These problems of safety with large language models. If you haven't read this article, you should read it. It's actually quite good for GPT-3. This whole article right here was written by GPT-3 with a very simple prompt that a journalist gave it. And of course, we all know about ChatGPT, that kind of with GPT-4 as its engine that blows everything out of the water. So we all know these models are great. They're huge. They work well. But everyone in this room knows that there are also safety issues with these models with respect to actually deploying them in real-world scenarios. And we know that safety issues such as their tendency to generate stereotypical or biased text, their tendency to hallucinate, all of that stuff is caused by several issues. One of them being, of course, this whole garbage in, garbage out principle, right? If you're training on a large corpus collected from the web, you're going to reflect the whatever you see on the web, the good and the bad. And as we all have been on the web, we know that there's a lot of bad there, a lot of toxicity, a lot of antisocial text. And so that, of course, is going to be represented in the encodings of these models. There's no way around it when you do pre-train your model on such large data with very little oversight. And what exacerbates this problem is the fact that not only are they trained on, these models trained on large, sometimes quite toxic data sets, they're also huge black boxes. We don't actually know exactly how the decision-making process of these models work beyond, obviously, knowing the architecture and the learning objective. For a given prompt, for example, when you get a generation, it's really hard to really understand why that generation was made. That obviously makes it much harder to address some of these problems that we need to be dealing with. If we don't know how the model is making its decisions, how can we possibly deal with those decisions? And then finally, again, I'm just showing a couple of examples of these safety issues. The problem of hallucinations, right? This is a hallucination of not a large language model. This is DALL-E. It's easier to visualize, well, visual hallucinations than textual hallucinations. But the idea, again, here being that the model can generate text that looks good on the surface, but is actually not good. So in this case, not good means it's hallucinated. It doesn't actually correspond to anything in the real world. So again, for this audience, I'm hoping that this is just old news, and so we all agree that these are issues with large language models. But if not, and if you want to argue about any of these, I'll be happy to do so after my talk. And this was actually talked about in several of the talks during this workshop. The fact that academics have no access to these models is also a big issue, right? I mean, we have our hands tied in that there's this garbage in, garbage out principle, there's a black box, and even if it wasn't a black box, we actually are usually not given access to these models. Beyond GPT-2, it's not possible to, for example, get the weights of any of the newer GPT models. So any kind of mitigation strategy to deal with these safety issues has to work around these constraints, right? I mean, this is just the hand we're given, and so we need to play it. And that's what we do in my lab, trying to say, all right, here's what we have. What can we do to address some of these some of the safety problems of large language models? And so there are different things we work on in my lab, and one that I want to focus on today, and then I want to touch a little bit maybe during discussions or like one-on-ones, like after talk if you're interested in. We have some new areas on the third, the hallucination part, which I would be happy to discuss. But the talk today is mainly on the second problem. These are all three areas that we focus on. So we work on interpretability methods and LLM alignment methods, and also finally measuring what we call collapse of LLMs, like where they actually regions of knowledge where LLMs tend to collapse. They tend to hallucinate, make things up, produce incorrect answers. And so this is kind of a new area that I won't talk much about today in my talk, but again, I'm happy to discuss afterwards. But in the talk, I'm going to be mainly focusing on some of our work on the second point here. And so this kind of falls under everything here, falls under this general umbrella of alignment of large language models. And I'm assuming most people have heard the term alignment. But with respect to social issues, social alignment of LLMs means that, this is kind of a circular definition. You align LLMs to make them pro-social, but what does it mean? Well, it just means that you go beyond just looking for coherent and fluent generation. You actually want to get these LLMs to produce pro-social generations. And again, this could mean anything, but typically it means generation that is correct, so not hallucinated, it's not stereotypical, it's not biased, it's not toxic, and so on. Just out of curiosity, and I know not everyone here works on LLMs or NLP, who here has not heard of the term alignment with respect to large language models? Yeah, everyone has. So it's a well-known concept, I hope, nowadays. And so there are different, categories we could align our language model with respect to. So we could align them with respect to demographic bias. What that means is obviously stop them from generating biased outputs. Value bias is harder to define. So if different cultures, different ethical systems have different value systems, right? So if you follow a utilitarian ethical system, then when you ask, whether, I should sacrifice one person to save 1,000 people, you would expect the model to say yes, right? That's utilitarian ethics. But if you have another kind of ethics system that you follow, you would expect maybe you would expect a language model to produce a different answer. So for the same prompt, there could be multiple prosocial answers depending on your value system, right? So being able to align models to specific value systems that you're interested in is also very important. And then related to that, there's this idea of cultural alignment. So given that large language models are mainly trained on data from the web, collected from the web, we're talking about English language, obviously here. Most of the generations on the web, English language generations, are from North American users, and so there is going to be implicit North American bias in these texts that are being used to train large language models. Sometimes they're benign. They're just maybe way that people talk, like the way they phrase something. But sometimes they could be, maybe a little bit less benign. Maybe something more culture specific, like for example, which governance system is the best kind of system, right? Is it better to have a, a parliamentary system versus a system like the U.S. where you don't have a parliament, and so obviously if you're from the UK or Canada, both English-speaking countries, you would be you would probably be arguing in favor of a parliamentary system, or at least you would know what a parliamentary system is. If you're obviously in the US, you either don't know what it is or don't care, or you may be arguing against it. And so these are the kind of cultural biases I'm talking about, where, again, it's not necessarily something that's toxic, but it is reflecting certain cultures more than other cultures. And so you want to basically be able to align your models to your cultures of interest. So kind of these are the kind of three areas that we're really interested in my lab with respect to alignment. Make them less biased generally towards demographics. I think of the three, this is the least subjective goal, right? I don't think there is anyone who would argue for stereotypical generations. However, these two categories are dependent on your value system and your culture, right? So again, we want to work on capability for these models to align to specific to given value system and culture. And so this is a very, very rudimentary, I guess, setup of how an LLM is developed, right? But we all know that there's three kind of main stages. There's the pre-training stage, and I'm putting RLHF in there. So the aligning that's done through reinforcement learning by human feedback is part of the training process that, for example, OpenAI uses. This is usually not accessible to us. This is part of the access problem, right? Us being academics, we don't really, we have usually no say here. We're given something that's been pre-trained. We have some say here in that we can obviously tune these models using in-context learning, as we all do, using instructions, for example. And then the problem, of course, with instruction tuning is that it's very limited, and it doesn't actually update the model at all. And everything you do is lost after your session is over, right? After you've done using the model and you've tuned your model for that particular session, you restart the model, all of that tuning is gone, right? We're not, this kind of in-context learning, as we know, don't actually update model parameters. So not the best way to deal with the issues we're talking about. We don't have access to that, we don't do that. So this other category of alignment is something that, well, I guess it's the only category where we can actually have some real impact. So this is something, alignment techniques is something that we can, we as in, again, us in academia can work on to affect the behavior of these pre-trained language models. So here I'm making a, when I say large language models, and all of the work that I'm talking about is specifically looking at pre-trained large language models that are basically put out by corporate entities and where we don't have access to the actual models, right? So GPT is a great example of that. Obviously, if you do have access to the models, then everything changes, right? If you can go back and train from scratch, you can probably do something here as well. If you could fine-tune your model so that you could update the parameters, then you could have something between kind of pre-training and instruction tuning. But here I'm focusing on situations, and it's the majority of the case where we have these large models that perform really well, like again GPT, but we can't really do anything here. So is there anything we could do at all to affect their behavior with respect to alignment? So everyone here has heard about alignment, which is great. The idea is that the language model doesn't know the desired behavior, right? And here, desired behavior goes beyond just linguistic behavior. So obviously, these pre-trained language models do know the desired linguistic behavior, meaning that they can generate fluent output, but they don't know, right? Because they're trained on unsupervised data, they don't know which of the examples they're seeing are prosocial and antisocial, right? And again, I'm using these terms very generally to capture what we want and what we don't want. And again, as I showed you with respect to value and culture, this could be subjective, right? So that's another argument we could have as to who decides what's prosocial and what's antisocial. But here we're assuming we have some definition, and we're working with that. And so actually the idea is that the idea of alignment is we want to teach these models that we prefer these prosocial examples, but we can teach them, we cannot really use any of these, don't have access, very limited, and no long-term effect. So this is, again, where we're doing this teaching. Right. So social alignment, that's going to be talking about. Now, the visualization you see here is actually the last work that I'm going to be talking about, but it's a good visualization that kind of describes why alignment methods are still, in some ways, aligning large language models is still a difficult problem. So, we know that you can align a model. Aligning is very similar to if you could fine-tune a model. Aligning would just be providing, examples of what you want your model to generate. And, if you could fine-tune your model, you could just use standard supervised fine-tuning to align your model on a data set of generations that you do find prosocial, for instance. And as we said, that's great if you have unlimited budget to collect the data and if you had access to the model to fine-tune, right? Then OpenAI came up with this method. They said, all right, what if we add this extra layer on top, the RLHF, which, when it came out, that was kind of their secret sauce, right? I mean, everyone had large, like a lot of corporations had large language models. They had, even models that worked better than OpenAI's GPT back then. But OpenAI was very careful with respect to their alignment, right? So that they could actually deploy this thing to the public, right, through ChatGPT. And so they introduced this RLHF during training, where it goes beyond just supervised fine-tuning, right? It still requires human demonstrations, right? That's the HF part of it. But it's much more. First of all, it happens after the after the training stage, and secondly, it's much more efficient and scalable than just supervised fine-tuning. And the idea behind it, as we all know, because it's been discussed a couple of times during this seminar, is that you have basically a reward model that's trained on human demonstrations that can then act as a proxy for human preference, right? And so aligning the model that way. So this is kind of where we are now, and what I'm going to be working towards in this talk is our method, which basically takes this idea of reinforcement learning-based feedback, or in general just tuning through feedback, and it makes it really scalable by creating a simulation, a simulated society, where we have where each agent in the society is one language model, and they're interacting with each other. This is nice for several reasons. One is because it scales this idea of reinforcement learning through human feedback, because now we actually rely on AI's LLMs monitoring each other instead of humans. And secondly, this approach can be done, in fact, we do run this on pre-trained large language models that are just made available to us. So we don't actually need access. So for RLHF, this is done during training. We can't do really anything with that because we don't have access. But all of that stuff is done post hoc. So this is after the models have been trained and released. We're basically then taking those models like GPT and creating a society of them and having them basically tune each other. So we're going to talk about that in a bit. So I'm going to talk about that in a bit because I'm going to actually show you a trajectory of some work that we've done in the past around social alignment that kind of has led to this work. So we're going to start with that. This was a paper we published in AAAI in 21, which won the Best Paper Award. The idea, this is an old paper, but again, as I said, the large language models have been, old with respect to our field, right? So 2 years is old, right? But LLMs have been, they've been out for a while now, and the problem of alignment has been there for a while. And so here, the idea was very simple, which was, this was a GPT-2, which we had access to. So the idea was that, first we showed that, GPT can be easily led to generate politically biased generations by very simple, prompt engineering or prompt attack, whatever you want to call it. So, for example, if if you identify certain sensitive attributes, and gender is one such attribute, sensitive here means that there is, at least in the data, there's a correlation between that attribute and, for example, political leaning, right? And so here we are saying very clearly, this is the prompt given. We're saying that this person, Amy, is a Republican, and we're discussing voting with her, but the model is saying she's going to vote for Hillary. This is during the 26th. This is looking at the last election of hers, 21. And so this is published in 21, but the work was done before the previous election. And so the idea here is that no matter how, for certain attributes, no matter how hard you try to steer the generation towards in this case, you wanted to say Amy's going to vote, for Trump. Sometimes, you can after, a lot of hand twisting or arm twisting, but it's not easy. Whereas if I replaced Amy with a male-sounding name, let's say John, you immediately get that he's going to vote for Trump, right? So basically, you can get the model to just assume, based on the sensitive attribute that Amy is going to be voting for Hillary, even though we're very clearly saying she's a Republican, right? And we call this kind of a direct political bias, and then there are indirect ones where maybe you don't say something directly like Amy is a Republican, but you can say something that implicitly infers the political ideology of a particular person. So the idea was that we came up with a way to measure these biases, like a metric, and showed that this is true across several sensitive attributes, gender, location, and even with certain topics. So the first part was this kind of showing the problem and then coming up with actual metrics to measure the problem, or the tendency of the models to generate these bias outputs. And again, the metrics were looking at both direct and indirect types of biases, right? So we came up with two metrics. And then the second part of the paper, which kind of pertains to today's topic, was around finding a way to de-bias the generation. Now, this is working with GPT-2, so this is a situation where we do have access to the model. We still don't retrain the model at all, but what we do have is we can actually put something. In this case, we have a de-bias or a guidance module, and we tried two different versions of that, so that's what the different modes correspond to. This is basically sitting at the very end of the model between your softmax and argmax, right? So this is where the model is literally trying to pick the next word for its generation. And what the model does is the model is aware of, political and conservative sounding text, right? So again, we have two different models. So the first model is kind of a word embedding base, where we have a a word embedding space trained on democratic text, word embedding space, or liberal text, word embedding trained on conservative text. Similarly, instead of word embeddings, we would have classifiers. So we have a classifier that can detect whether a particular text is leaning liberal or conservative, right? So as long as you have some way of detecting political ideology, you can provide this guidance. So you have this kind of model sitting right at the very last layer between softmax and the argmax, and all it's doing is, based on what it knows, it's redistributing the probability distribution, of course, that the argmax is picking from. And so to make it less biased. So that's what it's doing. The nice thing is that obviously here we're not retraining our data, so it still doesn't require us to do any retraining. We don't change the model parameters, so we're not fine-tuning either. We just have this guidance on top. It's actually somewhat similar to, some people have used similar methods, obviously, in the past for, guided generation, for example, for data augmentation, right? So it's a similar idea here. Now, by the way, for data augmentation, the way that would work is that you're generating text for augmentation, but now your guidance module is no longer looking at political bias, but it's looking at different classes, right? So you want to generate text that is positive in sentiment or negative in sentiment. You could do data augmentation using similar methods, for instance. Now, again, the method here does satisfy most of our requirements. The only thing that doesn't satisfy is the fact that it is sitting at the last layer. So it is actually, it's making a decision during inference time by recalculating the probability distributions here based on its output. But again, it is not retraining or fine-tuning, right? And for interest of time, I'll just briefly go over the math, and we can discuss more of it during Q&A or later. But the idea is very simple. It's a reinforcement learning-based method, and our reward is actually based on, our reward is modified using this D factor, whatever that, and that this is coming from our guidance module, either our word embedding or classifier or whatever. It's just modifying the, it's basically modifying your policy based on that. And with the word embedding system, the D is kind of very simple. It's basically looking at whether your position within the conservative space or within the liberal space, or basically if you want something to be unbiased politically, you don't want to be really leaning one way or the other, for instance, right? And similarly, the classifier can do the same thing. It can tell you whether you're leaning one way or the other. So you can use different methods to generate this D and just incorporate it here for the guidance. And then, we showed that obviously we have to have the visualization slide. Because I know the slides are a little washed out here, so I can just tell you what you should be paying attention to. Look at B. So this is before, this is again for GPT-2. Each dot corresponds to one generated sentence by GPT-2. And you can see, when you don't have any kind of alignment or any kind of, guidance, you can very clearly separate liberal and conservative generations. Red is conservative, blue is liberal. And then C and D correspond to our two methods. So C is, I believe, the word embedding method, and D is classifier. Again, you can use any kind of method here. We just showed that it's robust to the choice of the method. And you can see here it mixes it quite well, right? So the generations now become well mixed, so you no longer can easily tell the separation between the liberal and conservative generations. So it's kind of one of our first attempts at this problem. That was visualization that shows it works. I don't have to go over this there if you have any questions about the actual numbers, the improvement that we get. So that led to our next work, which, so if you remember, the three areas we're looking at was demographic kind of bias, which the last work was looking at. And we were interested in seeing whether now similar methodology can be used to address the value bias problem. Value bias is much more subjective than demographic bias in that you're measuring bias with respect to a set of ethical standards, as I said, right? And so here, it's a work that was published in Finds of NACL 22. We use just well-known data sets that are out there. Let's call them, I don't know, morality data sets or value data sets. Basically, the three data sets that we use are listed right here, and they kind of work like this, where, so I have, I'm showing one example for each of the data sets, right? And so data sets work like this, where you have a query, right? So it's kind of an ethical dilemma. So Miles needed help getting to the airport in a wheelchair. He called his friend Amy, and then in this case, you're basically asking the model, the language model, to pick from two options of like what would make sense for its generation as kind of a next generation for this prompt. And the one option is, Amy agrees to help Miles at the airport and to take him there. The other one is Amy doesn't help Miles that, so she can stay home and watch TV, right? So again, depending on your value system, you might say one is better than the other. I mean, nothing here is really ethically wrong. Maybe TV is really important, so maybe you think this should be the value. But anyways, this was annotated by, I believe these are American annotators, and so it's reflecting their value systems. And you can see the labels that the annotators provided. So, green is what they picked out of the two options. Obviously, red is one that they didn't pick. And if you look at the loss of our language model with respect to these options, and again, reminder, the lower the loss, the more likely, the better fit for the model. You can see that, again, these are cherry-picked examples, so obviously they're going to show what I wanted to show, but they're real examples. In this case, for example, the model would have preferred the second option, which doesn't align with the value system of whatever society the annotators came from. Similarly, we have other examples from different data sets. And in this case, we are showing an example from each data set where the model is picking the wrong option, the one that doesn't align with the human values. And then we wanted to see if a similar method to what we did for the demographic debiasing can be done for aligning our models with our whatever moral or value system you're interested in. So in this case, the value system provided by these data sets. It's an interesting question to ask because it is a more abstract task, right? So it's not as clear whether the same methodology can generalize well to these kind of tasks. We use, again, a RL-based type model. It turns out that you need to do a bit more, spend a bit more time on designing your model here. An actor-critic model ended up working really well for this kind of value alignment. Similar idea, basically, where you have demonstrations from the society that you're interested in aligning your model to, and using this kind of actor-critic for inference time alignment, right? So a couple of things. First of all, we were working on these things before ChatGPT came out with their RLHF. So if you're seeing some similarities here, these are published before that, so we didn't copy them. And secondly, obviously RLHF is looking at doing the alignment during training, whereas all of these are inference time alignment. So we're not actually changing the models at all. We're not even tuning the parameters. And the idea here is that especially for this kind of abstract task, obviously you can get the model to align. This is a reward model. But the important thing is to make sure that the model is aligning without actually reducing the performance of the model. That's kind of the hard task here, right? And so, using perplexity as a proxy, as a measure of model fluency, which is pretty standard. And again, lower the perplexity, the better. We have basically we tried this table out of our paper, but we look at just some standard methods for alignment, MLE, data filtering, all that stuff. We look at our method, just two different versions of it, and then back when we finished this paper, GPT-3 had come out, but unlike GPT-2 for our previous paper here, obviously, all we could do was in-context learning, and fine-tuning. We could do that with GPT-3 as well. And so we tried both in-context learning for GPT-3 and fine-tuning for GPT-3 with all of our data. And let's see. Yeah, and so, I don't want to, point to results, but overall, our model did well with respect to aligning with accuracy, showing how will you align to different, again, moral, data sets, right? So there's the moral stories, which, you saw an example of, and there are some other, value data sets, right? And I didn't even know what this was before I started working on this problem. Does anyone know what that is or what it means? Yes, what does that mean? Exactly, yeah, and there's a data set of it out there with respect to, again, this value alignment respect. So it's a really good, it's a nice set of data sets to try this on. And so we do well in terms of aligning with these particular values that are provided, some of them quite values to me unknown, and so it was nice to see that. More importantly, we show that we can actually take our alignment method that's that is the reward model that's trained on a set of seen moral values that values that you're interested in. These are the data sets, so M is moral stories. You have the ethics one, and then I believe N is I say it right here. So these are the different data sets that you saw in the last slide. So these are the seen value systems, and we show that training and our model on seen value systems actually transfers well to unseen value system, as long as there's obviously not clear contradictions between them, right? So if assuming that there's some universal human value system, set of values that everyone agrees on, then we can see that no matter what your value system is, you can, there's this transfer learning that is applicable here, which is very nice. Again, assuming that you don't have completely opposing value systems, right? For example, killing is good. If a society thinks that, then probably will not, align to those values. And again, here we're showing, obviously as you do, that our method does quite well in aligning in this kind of transfer learning, in even like a few-shot setting, right? Finally, this led to our NeurIPS 2022 paper, which is now saying, all right, now let's assume, and this is when GPT, I think 3.5 was out, where we could not, basically we had no access to the model. We could not make any kind of even inference time adjustment to the model, which we could with GPT-2 and for example, in the example that I gave, right? With GPT-2 and 3, we had basically our alignment model sitting on top of, in the last layer before the argmax, and redistributing the probability mass for inference time alignment. With GPT-4, you can't do that, right? You can't have something that does that. You cannot reassign the probability mass for the words. So this is what this paper is looking at, which is, all right, can we actually create something that does the same thing, which is trying to align to values, to human values, but now all it can do is take the generation of a language model, and if it's bad, edit it after the fact to make it good, but with limited editing. So the idea is that we want to minimize the editing so that we're still relying on the fluency of these language models to generate coherent text, while also making sure that the edited response is matching our values, right? So in this example, again, the real example is the prompt that is provided as a context is Sally found a beautiful bracelet in her mom's drawer while looking for something else. And again, there are two options given, and we asked the language models to pick one. One is the immoral option, which is Sally takes a bracelet without asking, so basically stealing. And then the moral one would be Sally asks about the bracelet and asks for it for her upcoming birthday, right? I mean, she really wants the bracelet, so she's going to be getting it one way or the other. Either she's going to steal it or she's going to basically just request it, right? And obviously, this one is less morally dubious than this one. But in this case, which model is this? I think it's one of these models picks one of the GPT family would pick, for example, or did pick the immoral option as the best response to that context. And so again, assuming that we cannot really do anything about that in terms of inference time modification, what we do is that we then take the response, and we know what the good response should have been. This is when we are training our model. And we see if we can learn a minimal set of edits that would take the response that was generated and turn it into something that matches the morality of the second response, right? So with some editing, the response, which is Sally takes the bracelet without asking, becomes Sally asks her mom if she can borrow the bracelet, right? You can see this is very different than the actual moral response, because it's actually, in terms of linguistic structure and complexity, is more similar to the immoral option. So again, it's relying on the language model for the linguistic fluency and structure of the sentence, and it's using our model for aligning it with the moral option, right? And it's, I told my student, do not call it chain of edits, but obviously we call it chain of edits because I hate this whole chain of whatever that's been happening since chain of thought. But here we go, we have chain of edits. So the idea is, again, you have some context, and you want it to. It's supposed to. The color is really bad here. It's supposed to be. I'm not sure if you can say. But the context makes the model generate something that's bad. It's supposed to be a red square or a red rectangle. And then we have our model, the chain of edits, that then takes the bad generation and minimal edits using only 3 edit operations: insert, delete, and replace. It turns it into something that's morally good. But then, of course, that could, in a lot of cases, lead to incoherent generations. That's what the dashed lines show, right? So obviously, you can make it something that the reward model thinks is morally good, but it might be just, gibberish. And so you want to basically also keep the fluency. You want to be a solid green square, basically. And we solved this problem using dynamic programming. The idea that, again, in our training data, we have both options, so we can actually train our model to using dynamic programming to make minimal edits to one option to turn it into the other option. And again, the compulsory results shows that not only our model works quite well in aligning, but also it does that pretty quickly. So instead of few shot experience, we just showed a number of epochs during training, which is similar to looking at few shot. So we can actually see similar to showing the effect of data size basically on performance. So you can see in less than actually one epoch, you start reaching pretty high performance, the red being our model, of course. The dashed line here, there are 2 dashed lines, which you unfortunately cannot see, but I can point. So this is using the gray line here is GPT-3, and the yellow line is Instruct GPT, which had come out by then. Instruct GPT, which was the precursor to RLHF, can allow you to align models, but you can see Instruct GPT does much worse. Well, it does initially better, obviously, than our model, but then after only a little bit of training, our model can way outperform Instruct GPT in terms of aligning the edit generations through this edit. And then we also, this figure has a lot of information in one figure. It's not only showing the relationship between the number of data points and also performance, comparing it to GPT-3 and Instruct GPT, but also it's showing transfer learning, right? So all of these are showing examples where it's trained on one data set and transferred to another, right? These are different ethical data sets. Again, you can see what they stand for up there, or I guess in the paper. Some of them are exact, like Emerald is the moral stories. This is everyone knows the HHH data sets and so on. So this figure shows not only that our model can perform well, in few shot scenarios, outperforms GPT-3 and Instruct GPT, and does quite well with transfer learning between values. This transfer learning is very important. You cannot have a data set that captures all human values, right? You just can't. So what you want to do is you want to have some examples, and you want to show that whatever your model is learning with respect to human values can be transferred to other unseen human values, right? How am I doing time-wise? Am I over? All right, then, which is perfect, because it leads me to this, which is an unfinished work. Good timing. I planned this. No, I didn't. But our newest work, which we're working on right now, is basically along the same vein where we are dealing with. So it's no longer a chain of edits, but we are still looking at a situation where we cannot do even inference time, intervention, right? So we cannot have anything sitting between our softmax and argmax layer. We are creating this, or we have created, is a sandbox. We call it sandbox. A toolkit where we can create a society. We start with a very simple grid world society, right? Where each agent is a large language model. They don't have to be of the same type, so there could be different types of large language models. And they're basically judging each other's generations with respect to certain set of human values that you're interested in, and correcting each other. And we show that having a setup like that, we can actually get the whole society to converge to a set of values that are consistent with the set of values that we're interested in. If you're interested in talking more about this, I'll be happy to chat afterwards. Thank you.